Good morning. This is the neuron diagram of an action potential. I just want to start off with a few key points. The stronger the stimulus, the bigger the ripples. Sodium and potassium flow with their concentration gradients. Voltage gates are always closed until the stimulus occurs, and at rest the cell's interior is about -70 MV. So just to point out a few anatomy, this is the dendrite here, the axon hallux. The ones in black are the sodium voltage channels, and the ones in red are the potassium channels. The colored red is potassium leak channels, which are always open. And then the one colored in blue is the NAK pumps, which always pump 3 sodium out and 2 sodium in with the help of ATP attached. At the end is the axon hallux. The synapse is in the middle here, and then this is another cell called the postsynaptic cell. So step 0 is just maintaining a resting membrane potential, which has more sodium outside of the cell and more potassium inside the cell, which creates a negative environment around -70. Step 1 is when a ligand binds to a receptor, which opens the channels out of the dendrite. This allows sodium to flow inside of the cell down its concentration gradient, which adds positive charges to the local area. So that's the receptor. Sodium then allows it to flow in to the dendrite, creating a more positive area. These ripples means that the stimulus is stronger. It's going to go down the cell, passing each channel. So step 2, once the threshold is achieved, which is around -50 usually, the voltage gates open and sodium flows in. Positive charges cause depolarization to move to each gate, which allows sodium to come in. The action potential is a chain reaction of depolarization to the axon terminal. So that means the first gate will open, sodium will come in. Then the second gate will open, sodium will come in. Third gate, keep going all the way down until it reaches the axon terminal. Step 3, at the same time, a once positive environment has passed the potassium channels, and it will open the potassium so it can leave, returning the cell to -70. This is repolarization. So once that's at the same time, the red channels will also open, letting potassium leave, so then the cell can return back to its normal state. And step 4, once it reaches over here at the axon terminal, the calcium channels open up and cause vessels to fuse to the premembrane, which is this first axon terminal, so it can flow into the space of the synapse. So these vesicles are holding the message, or the protein or the hormone, whatever is trying to travel through. And these fuse to the membrane, and then once it's fused, it opens up into the space of the synapse, where it can then fuse again to the postsynaptic cell and further move down the chain of spreading the message. And in the final step, this stimulates the next cell to create a reaction triggering another action potential. And then acetylcholine breaks down from the neurotransmitter from the vesicle to be used again. This helps clean up the synapse so a new stimulus can occur. So in the vesicles are neurotransmitters which have acetylcholine, and this breaks down called endocytosis, so we can reuse them again and again for every message we want to send in an action potential. And this whole thing is an example of continuous conduction, which means that each channel has to open up. But if the channel was covered with myelin sheaths here, then it would just flow right through, creating a faster conduction. But since this is unmyelinated, each channel has to open up till the end And then final point, I just added a little diagram to show what is happening and when. So -70 is the start of the cell. This is the graded potential. Once it passes this dashed line, which is the threshold around -50, it shoots up, and then this is called depolarization, which all of the sodium is flooding in, creating a more positive environment, peak usually at +30. Then once it starts to go down, the calcium channels are opening up, which causes repolarization to go back down past the threshold. And sometimes it can go below 70, which is called hyperpolarization, which just means it's becoming even more negative. So that is the neurodiagram of an action potential, and I hope you can read it. Thank you.